Hello there, my name is Nigelargriffiths. I work in IBM Power Systems Europe on AX and Linux. This is an open source project, so contact me at nigelargriffiths@hotmail.com. If you want to find the information, then you can go to tinyurl.com/njmon. This is a series, we're at number 8 now on njmon, but it's a little bit different from the others in the series. Normally we have a chart that looks like this where the data goes into the Influx database and then graphed by Grafana. But in this case we have something else in the middle in here. So we're taking the JSON file that comes out of njmon, going through the nmonchart, and it's generating a web page directly, a .html file that you can then view in your browser. If you're familiar with nmon, one of my previous tools, then it had an nmonchart and you know exactly what's going on if you've come across that before. Now the original nmonchart is a Corn shell script. It's quite big and takes a while to do some processing. Here we have njmonchart. The output is going to look similar, but it's actually written in Python. Python understands JSON format and it can read it very quickly, and transforming data is exactly the sort of task that Python is very good at. So we give it the name of our Python program, and then we give it the name of the JSON file, the njmon output file. If you don't give it a second parameter, it'll work out what to do. You can see it just replaces the JSON with HTML. Alternatively, you could name a directory of your website and the name of the file you wanted on the website, and then you've got immediately available for downloading with the browser. That's up to you. The program is about 800 lines of Python. It's fairly simple stuff, and it's generating 36 graphs. Although I realise now that the GPFS stats, or the spectrum scale as it's called now, aren't actually on this list, so the list is going up all the time. There's 200 lines of code that generate the website and things for you, and so for each graph there's maybe 8 to 20 lines of code to add. This is very useful if you've got a one-off investigation, you haven't yet set up your InfluxDB and Grafana and you just want to have a look at one file or maybe a few VMs. You'll end up with the graphs in different tabs in your browser and you can quickly go between them to work out what's going on performance-wise. Or you could use this to do bulk graphing and generate lots of nmon files and generate lots of web pages and organize your website around that. I've already mentioned that Python understands JSON files, can read them very quickly. If you have 1440 data points, that's once a minute for a day, you end up with a file of 40 to 60 megabytes or so, and it will generate your HTML file in less than a second, so it's pretty fast going, which can be very useful if you've got hundreds or thousands of files to do with. So let's stop there and actually see nmoncharts in operation and the graphs it outputs. This is one of my workstations. It's called Sky G1216. It's a Power 9 processor in here. Only got 40 CPUs and a quarter terabyte memory. Yeah, it's not respectable for a workstation. It's one of the benefits of working for a large corporation. If we look around in here, I have the nmonchart for AX and Linux. These are two separate programs at the moment. We could merge those together just by having a big switch at the top that says, is it AX or is it Linux? Then we'll run a different set of code. We might do that later on. And we have two JSON files in here. The smaller one, Silver 2, is for Red Hat 7.6. It's actually the machine I'm running Grafana and InfluxDB on. And then I have another machine running AX 7.2, which is called Silver 5. So let's just clear the deck, find our files again. Let's use the time operation. We'll just run those. Got to get the right one. If you put a Linux file into the AX program, it's not going to work. It will just throw a wobbly at you. Okay, and we'll just run that. Okay, 1 1/3 seconds, not too bad. That is 49 megabytes of data. Let's do the same sort of thing for the Linux one. A little bit quicker. We don't make quite so many graphs for the Linux at the moment. That can be boosted up fairly easy. It's, 8 lines of code for every graph if it's simple static data. If it's one of those variable things where the number of disks change with different data files, then that takes a little bit more coding, but not a lot more. Here's my secure copy for Windows. I'll update that. There we are. There's our two files. Just highlight them and drag them to my local server, my laptop. And let's have a look at the AX one first. Got to be careful to open it and not edit this, otherwise it will stick into VI. Okay, let me just shrink that down so it fits. Okay, now the writing is fairly small. Again, I'm trying to use a small font size, but in here we have the configuration data. Oops, that pops up here, and we can see what's going on with our server. If we look at more interesting things, CPU cores in here, this is the time over the day. This is yesterday, so it's got a day's worth in here. I didn't say if you got a partial njmon output file, it works out that it ends with a comma, so there may be records that should appear in the future. It will delete the comma and finish the njmon file for you, and then ready it as a JSON file, so it actually auto corrects that. We can look at the megahertz in here. We're running at 4 gigahertz. How much are we overclocking? 119.4, so that's 19% overclocking. We have the CPU pool that's available that it's operating in, the physical CPUs and the logical CPU views of the world, which CPUs where the most of the work's going on. We have run queue in here, was it 2 to 4-ish? Okay. We have load averages in here. Something I didn't say, you can zoom into these things and actually have a look at more details as we go. And you do a right click to come back out. Okay, we've got system calls in here. I'm going to skip over some of these in here. Forking execs running at a reasonable level there. We've got interrupts happening. We've got decrementer interrupts. This is for somebody called Earl Jew, an AIX guru performance tuner in America. And we've got memory in here. What's going on? It's fairly static. It's just running programs exercising the memory. How many times it zero fills the paging space. We have the total megabytes per disk in here, read and write, and then we also have disk stats on a disk by disk basis over here as well. We have journal file systems, and we have the networks. This is an iceberg diagram, so it's reading at the top and writing or receiving and outgoing packets in here. Again, this looks pretty busy because there's so many data points on our little number of pixels we're trying to show that. And we have interprocess communication, absolutely zero, so no semaphores or messages happening in the system. If I flip back to here and open up the Linux one, we'll see it's a bit simpler in here. Again, we need to add some more graphs. Now we've got this all working. CPU totals, different machine. This one's actually running InfluxDB and Grafana, and this is an artificial workload happening in here. This is more sort of barely detect InfluxDB and Grafana running at less than 0.1 of a CPU. There's a Power 9 chip. Okay, we've got the megahertz in here, a bit lower than the other system. Top disks in here, it's only 2. One of them's doing most of all the work. Memory in here, but we can see it using a bit of memory up as it goes. Paging space, total read writes on the disks. Oops, there's a little massive peak dip in here. Wow, nearly 10,000K. 10 megabytes a second. That's not doing very much, is it? And we have disk busies, and we have networks in here, and the actual networks are broken out here. So apart from this little peak in the middle of the day, and we can see the reading and writing of the various networks in here. Okay, hopefully that's given you a little flavour of what it can do, what these graphs are. These will be building up over time. Tend to wait for people to ask me, can we have this graph? And then I'll go off and do it. Right then, that's the end of our part 8 of our series. Thank you very much for watching. As always, if you enjoyed this video or learned something, do give us a thumbs up in YouTube. Always good to get some feedback. Number 9 will probably be on VIO server, but that will be ready when it's ready.